Today I'm going to be talking about rational versus irrational numbers. Okay, so you may not know what a rational or an irrational number is, so let's go over the definitions of both of these terms first. So a rational number is any number that can be written as a fraction or a ratio of integers. Okay, so what I mean by that is any number that can be written as a fraction. So you know what a fraction is. 3 over 4. And so 3 over 4 is a fraction of integers because those are both whole numbers. 1 over 7, 12 over 1, those are all ratios of fractions of integers. So the more formal definition is any number that can be written as a fraction a over b, where a and b are both integers and b is not 0. Okay, so why can't b be 0? Remember, you cannot have a fraction with 0 on the bottom. That is undefined. Okay, so you will never have a fraction where you have a 0 on the bottom. That cannot exist. So those are rational numbers. You have been dealing with rational numbers for a very long time. So some examples of rational numbers are fractions of integers. You can see I've got some examples. But terminating decimals are also numbers that can be written as fractions. So you see I've put some examples over here. 0.25 is actually 1 over 4. 0.13 is 13 over 100. So any terminating decimal is a rational number. Also, non-terminating repeating decimals can be written as fractions. So non-terminating repeating decimals are rational numbers. So you see some examples. I've got 0.3 repeating is 1/3. 0.25 repeating is a rational number. 0.9834983498349834 is a rational number because there is a repeating pattern. 0.765765 and continuing is a rational number because it is a non-terminating repeating decimal. And finally, another example is perfect square roots because they can be simplified to be a positive integer. Square root of 16 is 4. Square root of 121 is 11. Okay? So these are examples of rational numbers. You use rational numbers all the time. An irrational number is a number that cannot be written as a fraction or a ratio of integers. All irrational numbers are non-terminating, non-repeating decimals. And the most famous example of an irrational number is pi. Okay? We've talked about this in class, that pi is a number that never repeats. It keeps going on and on and on forever and ever and ever. Pi is an irrational number because it is a non-terminating, non-repeating decimal. Some other examples of that, again, you see I have pi here. I wrote out the first digits of it. Non-perfect square roots are all irrational numbers because they are non-terminating, non-repeating decimals. So you can see I wrote out the first few digits of square root of 2, square root of 3, square root of 5, square root of 6, square root of 7. Every single non-perfect square is an irrational number. Also, fractions where a or b, the numerator or the denominator, are not rational numbers are irrational. So you see that I've got examples here. 2 square root 3. Yes, it is a fraction, but it is not a fraction of 2 integers. Okay, square root of 3 is not an integer. Integers are only our whole numbers that are either positive or negative. So this is not a rational number. It is irrational. So you look at all of these and you'll notice that every fraction has an irrational number in it. So if the fraction has an irrational number as the numerator or the denominator, then it cannot be a rational number. It is irrational. So looking at the ideas of rational versus irrational numbers. So we're looking at how they relate to each other. So the sum or product of two rational numbers is always going to give you a rational number. So I've got some examples. The square root of 16 plus 14 is 18, because we all know that the square root of 16 is 4. So 4 plus 14 is 18. A whole number can be written as a fraction over 1, so all whole numbers are rational numbers. So the sum or product, so that goes for multiplication as well. The square root of the square root of 4 times the square root of 4 is the square root of 16, which is 4. Okay, so that is a rational number. 2/3 times 2/3 is 4/9. That is a fraction of two integers, so it is a rational number. So the sum or product of two rational numbers is always rational. Then the sum of a rational number and an irrational number is always irrational. So think about what we've been doing with our radicals. Square root of 2 plus 4 square root 2 gives you 5 square root 2. Since the square root of 2 is an irrational number, then 5 square root 2 is an irrational number as well. Pi plus 7 is 10.14159, and it keeps going on and on and on forever and ever and ever. Since it is a non-terminating, non-repeating decimal, it too is a irrational number. Okay, so make sure that you have those straight. When you add or multiply two rational numbers, you're always going to get a rational number. When you add a rational and an irrational number, you're always going to get an irrational number. So these are some things that you need to memorize and think about why they make sense. Now we're going to go into more stuff about multiplying, dividing, adding, and subtracting rational and irrational numbers in class. But you have to be able to identify rational and irrational numbers, and you have to understand the relationships that they have when we perform mathematical operations on them, adding, subtracting, multiplying, and dividing.